Okay, so now to solve the worksheet from last week, starting with number 2. The worksheet was about molarity practice problems. So starting with number 2, it says calculate the molarity of 0.060 moles of NaHCO3 in 1,500 milliliters of solution. Okay, so they give us the moles, and they give us the volume in milliliters. But remember that the formula for molarity, which that's what they're asking us to find. So molarity was big M. I'm gonna write it here. Molarity was big M, and molarity equals moles of solute over liters of solution. So molarity is moles over liters. The moles are given to us right here, but the volume is given to us in milliliters. Okay, we need liters. So the first thing we need to do is convert 1,500 milliliters into liters. Okay, so the first thing you need to do is get 1,500 milliliters and convert that into liters. Okay, from the beginning of the year, when we did the King Henry died upstairs drinking chocolate milk, to go from milli to liters, we had to jump 3 spots to the left. So you could either get this decimal places in the back and move it 1, 2, 3 spaces to the right. That will be 1.5 liters. Or you could do dimension analysis, which is kind of similar to stoichiometry, in which we divide by the same unit. Okay. But to do this method, you need to remember that in 1 liter, there are 1,000 milliliters. And we put the milliliters in the bottom so that milliliters and milliliters cancel each other out, leaving us in liters. So I divide 1,500 divided by 1,000. It gives me 1.5 liters. So my first step was that I converted this milliliters into liters, so that then I could plug in moles and liters into this molarity equation. Okay, so now my next step is going to be to find big M, which is molarity, equals moles over liters. Moles was given to me 0.060 moles divided by the liters, which is 1.5 liters. I'm going to get the calculator, divide 0.060 divided 1.5, and it gives me 0.04. Okay, now my unit, instead of writing M mole over liter, right, I'm gonna just write big M, because big M already equals moles over liter. Mole divided by liter equals big M. And now my final thing is I need to write the equation, the compound that we're talking about, NaHCO3. And that's my final answer. Okay, to do number 3, number 3 says, what is the molar concentration? Remember that molar concentration, it is the same thing as molarity. So they're asking us for the molar concentration, which is the same thing as the big M, moles over liter, of a 1 mole of potassium chloride dissolved in 750 milliliters of solution. Again, here they're given to us in milliliters. The first thing that we need to do is convert it into liters, because our equation is moles over liters, not milliliters. So I'm going to get 750 milliliters and divided by 1,000 milliliters in 1 liter. Remember that you could also get your decimal place and move it 3 times over to the right. 1, 2, 3. Okay. So it's 0.75 liters. So there, 750 milliliters equals 0.75 liters. And the reason that we do this first, remember, is because we need the units in liters. So now we could use our molarity formula, big M, which is moles. It's given to us in the problem, 1.0 mole divided by liters, which we just figured out, it's 0.75 liters. I divide 1 divided by 0.75 and I get 1.33. Instead of writing moles over liter, because remember that's here no units get crossed out, I'm going to have moles over liters. I'm going to write big M and then the equation that we're talking about, potassium chloride. And that's my final answer. Okay, number 4 says calculate the molarity. Again, molarity is moles over liters. How much solute for solution do we have? Of 29.25 grams of sodium chloride in 2 liters of solution. So here the volume is already given to us in liters, which that's good. So we don't need to do anything with this. We do not need to do this because it's already given to us in liters. But instead of giving us moles, they give us the grams of sodium chloride. So what we are going to have to do is we're going to have to convert grams into moles. So we're going to have to convert grams of sodium chloride into moles of sodium chloride so that we could plug it into this equation. But this is not hard because we know how to go from grams to moles, and that's by using the molar mass. Okay, so I'm going to start with 29.25 grams of NaCl, and I'm going to do stoichiometry. The first thing I need to do is I need to find the molar mass of NaCl, which remember you get your periodic table, you add the mass of sodium plus the mass of chlorine, and that gives you 58.44 grams of sodium chloride for every 1 mole of sodium chloride. Like this, the grams get cancelled out. I'm left in moles, and I'm going to divide 29.25 divided by 58.44 to get 0.50 moles of NaCl. Okay, now that I have my moles, now I could use my molarity formula, which is moles, 0.50 mole, divided by liters, which the problem already gave it to us, is 2.0 liters. Divide 0.5 divided by 2, it gives me 0.25 molar sodium chloride. And that's my final answer. Number 5 is the longest type of question. Let's read it. It says calculate the molarity. So they're asking us for molarity. Again, molarity is moles over liters of 34.2 grams of sugar. Again, they're giving to us the grams, not the moles. So we're going to have to use the molar mass of sugar to go from grams to moles of sugar. And instead of giving us the liters, they give us the milliliters of the solution. So we're going to have to convert the milliliters into liters by dividing it by 1,000. Okay, so we're going to have to do 2 steps before we can plug it into our molarity formula. So the first thing I'm going to do is I'm going to turn 34.2 grams of sugar, which is C12H22O11, into moles. Okay, remember that the way I do that is by figuring out the molar mass. So I have 12 carbons, 22 hydrogens, and 11 oxygen. I'm going to multiply 12 times the mass of carbon, which is 12.01. So 12.01 times 12 equals 144.12. Then I have 22 hydrogens. So 22 hydrogens times the mass of 1 hydrogen times 1.01 is 22.22. Then I have 11 oxygens. So 11 times 16 is 176.00. I add all of my masses and I get 347.35. 347.35. The grams get canceled out. I divide, I get 0.0999 moles. Okay, the reason that I want to leave more decimal places because that's not my final answer. I'm going to use this to find my final answer. So now that we got the moles of sugar, now we need to convert 500 milliliters into liters by dividing it by 1,000 milliliters in 1 liters. The milliliters goes away, just like the grams went away. I divide 500 divided by 1,000, I get 0.5 liters. Now that both of my units are in the correct units, moles and liters, now I could use molarity equals moles, which I just found out it was 0.0999 moles over 0.5 liters. I divide these two and I get 0.1999, which I'm going to round to 0.2 molar of sugar. So C12H22O11. And that's my final answer. Okay, so my calculator gave me 0.1999. I'm just going to round it to 0.2. Number 6 says calculate the number of moles of sodium chloride contained in 0.5 liters of a 1.5 molar solution. Okay, so this question is a little bit different because they're not asking us for molarity. They're giving us a concentration. They're giving us the big M, the molarity. They're giving us the liters, and what they're asking us is for the moles. So what I'm going to do here is I am first going to rewrite the formula. So molarity equals moles over liters. Okay, now I'm going to get my values that were given to me and I'm going to plug them into this equation. So big M is 1.5. So 1.5. Now instead of writing big M, right, for molarity, I'm going to write its units. So I'm going to write moles over liter. Remember that moles over liter is the same thing as saying a big M, okay? Equals mole, which that's what the question is asking us for. So I'm going to write a big X on top of mole. And in the bottom we'll go liter, which it was given to us, 0.5 liters, okay? So now what I gotta do is I gotta use algebra to solve for X. Okay, I'm gonna solve it. I'm gonna do it the long way. So to isolate X, here X is being divided by 0.5. So to isolate X, what I'm gonna do is I'm gonna multiply both sides by X. Right? If I multiply both sides by 0.5 liters. And I'm going to here also multiply by, I'm going to rewrite it here. If I multiply 0.50 on this side, it cancels out. But here, if I multiply 0.5 liters times 1.5 mole over liter equals X. Okay, you're going to see how liters and liters cancel out, leaving the only unit mole. So to solve for X, what I have to do is I gotta multiply 0.5 times 1.5. Okay, and that gives me that X equals 0.75. Since the only unit left on the cross was moles, and that's what the question is asking me for, moles. It's mole, and we're talking about sodium chloride. So that is my final answer. Okay, I didn't really have to do this right here. I could have just said, okay, X is being divided by this number. To isolate X, I'm going to do the opposite. So I'm going to multiply 0.5 times 1.5. Multiply these two numbers to get the value of X. Now, the next question, in the one that I originally gave you guys, there was a typo. I skipped number 7. So I went from 6 to 8. And then here, it asks about number 7. Okay, but I fixed it in this one. But I send it in the remind. that there was a typo. This, we should be looking at number 6. Okay, so number 7 says, how many grams of sodium chloride are contained in the solution discussed in the problem 6? So basically what number 7 is asking us is just asking us how many grams of sodium chloride did we have to add here. Okay, well, we know how many moles we had. So what we gotta do is we gotta convert this number of moles into grams. Okay, because we know how many moles. That's what we did in problem 6. And problem 7 is asking us, well, how many grams is that? So I'm gonna start with the moles. 0.75 mole of sodium chloride. And I'm gonna turn that into grams by multiplying by the molar mass. So in 1 mole of sodium chloride, there are how many grams? Well, we did that earlier over here where we figure out the molar mass. So I'm not gonna solve for it again. I'm just gonna use the same number. Remember, this number we got it from adding the mass of sodium plus the mass of chlorine. So 58.44 grams. Like this, the moles cancel out. I multiply 0.75 times 58.44 to get that there are 43.83 grams of sodium chloride used in example 6. Okay, so what that means that I got a scale, I measured out 43.83 grams of sodium chloride, and then I added 0.5 liters of water to reach this concentration of sodium chloride solution. Okay, so number 8 says, calculate the number of moles. So again, they're asking us for moles of sodium hydroxide contained in 250 milliliters of a 0.5 molar solution. Okay, so this question is very similar to number 6, with the only exception that in number 6, they gave us the volume in liters already. Here, they're giving us the volume in milliliters. So the first thing we gotta do is convert that milliliters into liters. So then we could plug it into the molarity equation and solve for x. Okay, so first thing I'm gonna do is I'm gonna do 250 milliliters divided by 1,000 milliliters over 1 liter, and that gives me 0.25 liter. Remember that you don't have to do this step like this. You can just move the decimal places 3 times over to the right. 1, 2, 3, 0.25 liters. Okay, so now that I have the volume, the correct units, now I'm going to recopy my formula. Molarity equals moles over liters. And I'm going to plug in all my information in here. So molarity is 0.05 moles over liter. Right? Instead of big M, I'm going to write moles over liter equals moles. I don't know, that's what they want us to figure out. So I'm going to put X. And liters, 0.25 liters. So to solve for X, what I got to do is I got to multiply 0.05 times 0.25. Okay, I'm going to multiply these two numbers. 0.05 moles over liter times 0.25 liters. The liters cancel out, and I get 0.0125 moles of sodium hydroxide. And this is my final answer. And the last problem says, how many grams and moles of solute, remember solute is what we're adding, are there in 250 milliliters of a 0.1 molar calcium chloride solution. Okay, so here a lot of information. They're asking us for 2 things and they're giving us 2 things. Okay, so we're gonna do one thing at a time. First, okay, so the first thing we're gonna do here is we're gonna convert this milliliters into liters, because remember that for molarity we want liters, not milliliters. So So the first thing I'm going to do is I'm going to turn 250 milliliters into liters by dividing it by 1,000 milliliters over 1 liter. That gives me 0.25 liters. Okay, so the first thing I did is I converted my milliliters into liters. The second thing I'm going to do is I'm going to use my molarity, moles over liters equation to solve for the number of moles. So molarity equals moles over liters. Okay, molarity, it was given to me 0.10 moles over liter equals X, because I don't know my moles, they want me to figure out the moles, divided by liters, 0.25 liters. To solve for X, I'm going to multiply 0.25 times 0.10. X equals 0.025 moles of calcium chloride. Okay, and that's part 1. So I just figure out how many moles of solute I have. I figure out the moles. Now they're also asking me to find the grams, okay, and that's easy. Now what I gotta do is I gotta go from moles to grams. Okay, and remember I do that by using the molar mass. So I'm gonna start with 0.025 moles of CaCO2. And in this case, I'm gonna multiply by the molar mass. Okay, the molar mass, I get it by multiplying the mass of 2 chlorine. So 2 times 35.45 plus the mass of 1 calcium, which is 40.08. I add those two and I get 110.90 grams CaCO2. The moles get canceled out. And when I multiply 0.025 times 110.90, I get that I have 2.77 grams of calcium chloride. That is my second answer, and I'm done.